Hello there and welcome to our second class of our semester, Physical Geography, Spring 2026. I can't be with you physically today. I have to be in Germany for a funeral service, but Professor Kons is here and we're just going to run this class as sort of a video lecture here for you. And we're going to start on our course website. The link to the course website, you can find that on Plato. I also emailed this to you, of course. And as part of the assignment that's due today, you already explored the website, so you have a pretty good idea what's going on here. Up here under classes, if you click on this is all the classes that we're going to have, right? Part 1, that's what we're in. Today we are Physical Geography and Course Overview Part 2. That's today. And then next week when I'm back, we're going to cover the nature of science and then mapping the Earth and so on and so forth. This tab up here takes you to the labs and to the field trip. And then up here under assessment, you can find our worksheets, our assignments basically, and then our tests as well. For each test, you'll get a study guide and a practice test. And then under resources, you looked at this for the homework. We have all kinds of cool stuff, including these free online textbooks and other resources that you can use for this particular class. So let's go back to classes here, right? So, that didn't work, classes. Here we go. So Physical Geography Part 1, Class 1, we did that on Wednesday. So today we're going to do the second class of that. And let's just dive right in. Click on the course overview and bring up the slide deck for today. So here's what's on the agenda today. We're going to start with a little bit of retrieval and practice. We want to talk about landforms, and then we want to talk a little bit about processes. We have 2 handouts. They're not all that important in this particular case, but please keep them. We're going to use them in the future. For those of you who didn't attend class on Wednesday, Professor Kons has the syllabus and all the other materials that you received on Wednesday. In terms of announcements, worksheet number 1 is due. The course questionnaire is due, so please make sure you hand them to Professor Kons, and also please make sure that you sign in and sign the attendance sheet. So let's get started here with the class, and I want to start with a landform. Right? We always want to start each class with a landform and get sort of start practicing the way that geographers think about the physical geography, about the landforms of the planet. Now, here's a photograph I took several years ago. We were hiking in the White Mountains, and we're looking across a mountain that you can see here in the background. And some of you might recognize this mountain. Some of you may have even been on top of this mountain at some point in the past. And what we always want to think about is what processes are shaping this particular landform, in this particular case, this mountain here. And we'll come back to this mountain here in just a minute. But we always want to start every class with going back. Let's go back to the class on Wednesday and see what we can remember. And I have here a simple multiple choice question for you. Something that you might find on one of our tests. So, the word geography comes from the Greek meaning blank. So take a minute, take a look at the answer options and decide which one would be the correct one. I'll give you, let's say, 10 seconds. Okay, perfect. So, what is geography? Well, it's not the study of rocks. That is geology. Hey, it's B, Earth description. That is actually exactly what geography is, as we covered in our last class. Planet measurements, nope. Drawing of maps, sure, we do maps in geography, but the drawing of maps or the creating of maps is actually cartography. The study of weather is actually meteorology. So in this case, B, Earth description. Let's try another multiple choice question. Which of the following is a topic in a physical geography course? Landforms, rocks, climate, water, or is it all of the above? Let's take a few seconds and pick your answer. And it is indeed E, all of the above, right? We study landforms, right? We do cover rocks, even though, again, the study of rocks is geology. We will cover rocks because that is important in landform formation. Climate is a core part of physical geography, so we'll spend a lot of time on that. Water also, so in this particular case, it's E, all of the above. One more multiple choice question. The following is a fundamental question in any geographic inquiry. Take a look at the answer options and decide which one is the best answer choice. I'll give you a few seconds. Perfect, right? It is indeed E, all of the above. These are all fundamental questions that we ask when we think geographically, when we do geographic inquiry. What is it? Where is it? Why is it there? And then perhaps most importantly, how? How is it shaped? What are the processes shaping this particular landform? Fantastic, right? Nice review, retrieval, and practice of what we did on Wednesday. So, course logistics, right? We talked about this on Wednesday. Again, everything you need about this class is on this course website here. We use Plato only for your grades. So you will find your grades on Plato. But other than that, all the course material, the slide decks, the assignments and everything else is on this course website, right? Remember, you also registered for a lab, either for the lab on Tuesday or for the lab on Thursday. Those labs are taught by Professor Lally. Again, take a look at the syllabus, right? Take a look at the course website, familiarize yourself with the course, and then you're good to go. If you have any questions, if you have any concerns, please send me an email and I'm happy to respond as fast as I can. Remember the field trip, right? So on Wednesday, April 22nd, we will go on an all-day field trip. We're going to rent a bus and we're going to drive all around Western Massachusetts to look at all the cool landforms that we have in our neighborhood and learn more about why our home, why the place that we live, that the place we call home, looks the way it does. So it's a fantastic day. It's a highlight of the course. Just keep in mind, put that in your calendar so you are aware of that. And we'll talk a lot more about the details of this field trip as we get closer. Now, let's talk about landforms, right? So let's look at a few examples. Again, we already, looked at a few examples on Wednesday. Let's take a look at a few more examples. And we start, at the Grand Canyon once again, right? This is an old photograph. This is probably 10, 12 years old. I'm standing at the edge of the Grand Canyon. We're looking into the Grand Canyon, one of the most spectacular landforms on Earth. I hope you get a chance to visit one of these days. But again, we're looking at the spectacular landform and we immediately want to ask these questions. Well, what is it? Why is it there? What processes have created this gigantic hole in the ground, right? This is like hundreds of miles long, tens of miles wide, and it's basically a mile deep. So some natural process, in this case fluvial erosion, created this landform, and we want to learn about these processes that have created this landform. Arguably super spectacular, right? But the same way of thinking applies to any landform. So let's go somewhere else. All right, here we are, right? When you look at this particular landform, you're like, okay, we're in the mountains somewhere. But when you look at this, I think what kind of becomes interesting is like, well, why is there this boulder on top of a mountain? Well, here's another boulder here. How did these boulders get on top of these mountains? Right? So again, we're asking ourselves these questions about processes. What natural process, what geographic processes could have possibly led to this situation that we have this gigantic boulder that I'm trying to push over here on top of this mountain? Now, where are we? Well, we're in some mountain chain. We don't really know where we are, right? You can't really necessarily tell this from looking at the photograph. We're above tree line, right? And this actually turns out to be that we are in the Adirondacks. And the mountain here in the background is Mount Marcy, which is the highest mountain in the Adirondacks. And here I am on the mountain next to it with these two big boulders on top of it. How did the boulders get there? right? And we'll talk about this. And in fact, we'll see similar boulders scattered all around Western Massachusetts. Well, how did these boulders get there? Right? Can't be wind. These are way too big to be blown up to the top of this mountain by wind. Can't really be a river, right? So indeed, this was a glacier. At some point, right in the past, a glacier transported these rocks and dumped them, in this particular case, right on the top of this mountain. Well, now we can ask all kinds of other questions. Well, what happened to the glacier? The glacier isn't there anymore. Why was there a glacier there? What happened? Right? And so now we begin to think geographically, and we can begin to think about processes that are shaping this landform, that are shaping Massachusetts, that are shaping New England, or that are shaping the world. One more landform. What is that? Right? So here we are somewhere. In this case, we're on the summit of Mount Equinox in Vermont. And you see my wife here standing on this white rock. Now, this is a little interesting because this rock doesn't look natural, right? It looks like it was cut. But what's interesting about this rock is it's the color of it. It looks basically like a cube of sugar. And what this rock is marble. And then you're like, well, marble? Didn't know we had marble in Vermont, right? Now, in this case, of course, the marble blocks were placed there by humans, probably by some backhoe. But then it's like marble. Right? So we're going to learn a little bit about what marble is, right? And actually turns out that the largest marble quarries in the world are actually located in Vermont, right? So again, here we're looking at a natural landform, the summit of Mount Equinox, and on top of this, we have a rock, in this case, a piece of marble. Again, telling us a story about the landscape, telling us a story about the history of this landscape. And again, we'll talk a lot about this concept of, well, plate tectonics, the rock cycle. How do rocks shape? How are rocks shaped? How do rocks change over time? Fascinating story here. So again, this question of geographic thinking. What is it? Where is it? Why is it there? How is it possible that it is there? And then how relevant is this? Right? Who cares about the fact that there's marble in Vermont, right? So we need to think about that as well. So this is a little bit more about landforms, and you can sort of have this sort of thinking anytime you look at any landform. What is it? Where is it? Why? How? And how relevant is it? Why is it relevant? That's the story of landforms. And that then, right, you can do yourself, right? You can think about landforms yourself. Think about a mountain, think about a stream, think about a pond, think about a lake, think about a waterfall. Think about all of these landforms and begin to think about like, hey, right, why is this place interesting? What is going on there, right? Why do we have an ocean? Why do you have a river delta? Why do we have an island? What processes are going on shaping this particular landform? And we'll pick up on this in the subsequent weeks, again, always looking at landforms and then thinking about the processes that have created it, right? So let's talk a little bit more about processes, right? When we think about processes, we want to think about these big picture separation between what we call endogenic processes and exogenic processes. We'll get back to that in just a minute. Now let's look back at this photograph here, right? We started with this, let's go back. This mountain here is Mount Washington. So we are in the White Mountains, we're in the Presidential Range. The summit you can see here with these antennas on top. What you can also see here is the auto road that goes up Mount Washington. That's about 7.5 miles. You can drive your car up there, right? Another way to get up Mount Washington is using the Cog Railway. That's another good option to go. And of course, you can hike it, you can climb it, you can ski it, and all that sort of stuff. But again, when you're looking at something like this, you always have to think about that this landform is not static. This landform is changing as you are looking at it. The processes that are shaping this landform are constantly ongoing. So the only thing that's really constant out there is change. Now, most of these processes shaping, let's say, Mount Washington are so slow that while you're looking at it, it looks like nothing is happening. But if you were to sit where I'm standing taking this photograph, which is actually on Mount Jefferson looking south towards Mount Washington, right? If you were standing there for 10,000 years, 15,000 years, 100,000 years, you would actually see the mountain changing in front of your eyes. So that's the fascinating thing about processes, right? Processes are actually more interesting than the product. Landform development really doesn't end. Landform development is constant. The processes that are shaping the land are always ongoing. And what you're seeing in the landform, whether it's Mount Washington, the Grand Canyon, Mount Equinox, or some boulder sitting on the top of a mountain in the Adirondacks, is just a snapshot within a continuum of change. Nothing is fixed. Everything changes due to geographic, geomorphic processes. Right? The frustrating thing about these processes is rates of change and scales of change. What do I mean by that? Right? There are processes that are simply too small or too big for humans to see, quote unquote, with our own eyes. Right? There are processes going on that are just so small that happen at the microscopic level or even smaller that we just can't see. And then, of course, we have processes in the universe, processes on Earth that you can't see as a human with your own perception, right? The bigger issue is actually scale. Some processes are just too slow or too fast. In fact, most geographic processes are too slow to see because a process of change, let's say weathering, erosion, just takes tens of thousands, hundreds of thousands, millions of years before anything actually happens that you could see, quote unquote, right? So rates and scales really matter when you think about landform development. So let's go back to the separation between, generally speaking, we have endogenic processes and we have exogenic processes. Endogenic processes, generally speaking, happen inside the Earth, right? The perfect example here is something called plate tectonics, earthquakes, volcanism, those sort of things, right? Sometimes you can see the effect of these processes at the land surface, but generally speaking, these endogenic processes are internal processes. They happen below the surface of the Earth. And we'll talk about plate tectonics, volcanism, earthquakes, and the rock cycle here in this class. In contrast, we have the exogenic processes. These are the processes usually related to water, wind, or ice that happen at the surface of the Earth. Weathering, erosion, deposition, rivers flowing, waves crashing onto the shore, winds, groundwater, glaciers, all of those things are exogenic processes. They happen at the surface of the Earth, and they happen somewhat fast compared to these endogenic processes, generally speaking. So again, we can generally look at processes that shape the landscape in this sort of separation between endogenic processes and exogenic processes. Again, a lot more to come about these details and a lot more examples to come as we go forward in this class. Right. A couple of options here for you, right? If you want to explore spatial scales, if you want to see the universe, the scale of the universe, and all of those things from the absolute largest scale, which would be universes, Milky Ways, galaxies, down to subatomic particles, check out some of those animations or some of those videos. Powers of 10, absolutely fascinating. That sort of shows you just how big and small the universe and the Earth actually is. You can also look at temporal scales, and here's some fascinating videos that sort of depict to you the scales or time scales of Earth's evolution, right? Here's a good one, right? Kind of putting the entire Earth history onto a football field. And here's another good one, the evolution of life on Earth, as a very short, quick video. Fascinating stuff. So please click around here a little bit and check out some of these videos, and especially check out some of these animations that lets you zoom in into subatomic particles, and then you can zoom back out to the scale of galaxies. And it's a fascinating experience. So check those out. All right. Now, again, when you think about Earth, I want you to think about a complex and beautiful thing, but you also should realize that what happens on Earth isn't random, right? What happens on Earth is predictable through science, and geography really is the science of the Earth, right? And through geography, by understanding of geography, we can understand the Earth and all its complexity and all its beauty, and we can begin to understand it. We can begin to understand the past of the Earth and the future of the Earth. We just have to think about time scales, spatial scales, processes, and change. And that's what this class is all about. So, thank you for joining me today, right? This was class number 2. We did some retrieval and practice. We talked about landforms. We talked about processes. Grab those handouts and keep them with you. Again, if you weren't here on Wednesday, please see Professor Kahns. He has the syllabus and all the other handouts that you might have missed on Wednesday. And please make sure you hand in your worksheet that's due and the course questionnaire that's due. And then you're good to go. Make sure you sign in the attendance sheet. And then have a great weekend. And I will be back on Monday and we'll talk about the nature of science, what science is, what science can do for you. And please, if you have any questions, if there's anything uncertain, please don't hesitate. Send me an email. I am in Germany, but I'm very able to respond to emails rather quickly. Otherwise, have a good weekend and we'll see you back here on Monday.